Hello, and welcome to today's Environment and Energy Leader webinar titled Data Loggers Basics, Improving the Built Environment, sponsored by Onset. My name is Jessica Hunt, and I'm the Director of Events for E&E Leader. First and foremost, thank you for being with us wherever you are in the world today. In case you are unable to join this event live, it will be available on demand within a few hours. If by chance you are having any technical issues during today's event, please follow the troubleshooting tips located in the widget at the bottom of your screen. If you are still having issues after performing those steps, please feel free to send a message to me via the Q&A widget that is already open on your screen. Attendees do have the ability to chat with one another as well as me during the event today. So please send a message in the attendee chat window, say hello, let us know where you're calling in from and why you decided to join today. Onset was kind enough to provide all attendees with a copy of today's slide deck, so please take reference of the resources that are located in the attendee console. And as always, we will have time for Q&A with our speaker, so please do your best to submit questions for our speaker, Shannon Ryerson, over the next 50 minutes. If we do not get a chance to answer your question during today's event, a member of our team will follow up with you as soon as possible. And it gives me great pleasure to welcome Shannon Ryerson from Onset to today's webinar. And at this point, Shannon, I am going to turn the presentation over to you and I will rejoin everybody for the Q&A.
Perfect. Thank you, Jess. Thank you again, everyone, for attending. As Jess had mentioned, my name is Shannon Ryerson, and I am a technical sales rep here at Onset. Today's presentation, as mentioned, is going to be improving the built environment. Just a little background on me. As I mentioned, I am a technical sales rep here at Onset. I've been with the company for just about 4 years. I specialize in data logger selection and application support. And my primary market is indoor monitoring and built-in performance monitoring. Just a few additional webinar details that I want to go over that Jess had mentioned in the beginning. This webinar will run for approximately 50 minutes. We will save some time at the end to answer questions, so please submit those in the questions box. And the webinar is being recorded, which will be available within a few hours after the end of the presentation. So a little background on Onset. We are the makers of the HOBO data loggers. We are located in Bourne, Massachusetts on beautiful Cape Cod. Our sole focus is on accurate and reliable data logging and monitoring. We are a world leader in data loggers with a global network of distributors. We do carry an ISO 9001-2015 certification, and our organization was founded in 1981. So just to briefly go over the agenda today, we will cover what is a data logger, common applications for monitoring, ways to access your data. We'll also give an overview of HOBO Internet of Things monitoring solutions, also some important factors to consider when selecting a data logger. We are going to go over some frequently asked questions. I'll cover a few application stories, and then at the end, we will open it up for Q&A. So what is a data logger? A data logger essentially is an electronic instrument that records measurements at a set interval over a period of time. These devices are typically battery powered and compact, and they are equipped with an internal microprocessor, data storage, and one or more sensors. Data loggers, and specifically HOBO data loggers, can be deployed indoors, outdoors, or underwater. Most of our products can record data for up to years at a time, typically unattended. So here's a list of some built-in performance measurements that you can take with our devices and sensors. For environmental parameters, we do have sensors and data loggers for temperature, relative humidity, dew point, carbon dioxide, air velocity speeds, as well as VOCs. When it comes to energy or power monitoring consumption, we do have plug load data loggers, devices for monitoring kilowatt hours. We also have devices and sensors for monitoring your amps, volts, amp hours, volt amperes, power factor, both AC and DC current. We do have sensors that will capture differential pressure as well as gauge pressure. You are also able to record analog signals with our devices as well. And those cover, 4 to 20 milliamp signals, pulse signals, or DC voltage signals, which typically are in the range from 0 to 2.5, 0 to 5, 0 to 10, and 0 to 24. And these become essential if you have a third-party sensor that maybe doesn't record information, but you would like to record the information from it. As long as that device outputs one of these types of signals, you can typically connect it to one of our analog data loggers, set up the scaling, use an engineering acronym for that measurement, and then it essentially takes that analog signal and converts it to an engineering term with a measurement for you. Lastly, we also have several different time of use data loggers, whether that's light on and off, motor on and off, state changes, or occupancy and light data loggers. For our outdoor and underwater platforms, we have a whole array of different data loggers and sensors for recording multiple parameters. With water, we can do water temperature, level, conductivity, salinity, soil moisture, water flow, and pH. For our outdoor data loggers, we have sensors for temp and RH, PAR, which is photosynthetically active radiation, light intensity, which would be more of a wider band of the visible light from the sun, rainfall, wind speed, wind direction, solar radiation, and leaf wetness. And again, some other parameters we have are the analog signals that we can capture with our indoor products, as well as a tilt and acceleration data logger. So a little bit about the HOBO monitoring solutions. HOBO data loggers are research-grade devices and remote monitoring systems that put the power of accurate, reliable data at your fingertips so you can make informed decisions for a sustainable tomorrow. While it's always nice to make guesses on, what type of changes that you should implement, having some actual data to back that up is always essential to ensure that you're making the best decisions possible. With our data loggers, it does allow you to evaluate the performance and the impact of renewable energy sites, as well as green roof and spaces. It enables energy use insights to lower costs and conserve resources. And also it allows you to assess indoor quality and optimize HVAC systems performance to not only improve occupants' comfort and health, but also to help reduce energy usage. So here are just some common uses for our data loggers. And essentially what this is outlining is really just different types of our indoor and outdoor data loggers and where they would be applied. So for example, at the top with our occupancy and light, that could go inside of an office building where, say, you have conference rooms that are on automated lighting schedules, or they have sensors where they automatically turn on when people go into the room and shut off when there's no movement after a set determined amount of time. We have data loggers that will track, both the light on and off, as well as if there was people within those rooms. That way you could see if your schedules are working or set up correctly, and also are those sensors working correctly where they're turning on when people are in there, and again, shutting off after they're outside of the room. We also have temp and RH data loggers, which again could be applied to like a hospital setting, office space, any type of area where you would have occupants there and you want to ensure optimal comfortability for them. We have very low cost devices for tracking that type of data. A lot of times monitoring indoor parameters and trying to make educated decisions on what to do indoors requires you to take some outdoor measurements as well, just to see that correlation between what's the conditions outside versus what's the conditions inside. So we have several options for monitoring outdoor and climate conditions. Also, we do have water quality data loggers, which you typically see those more in like treatment facilities or wastewater plants to ensure that their discharge after it's been cleaned doesn't have any contaminants, or it's at a regulated temperature that won't affect the habitat that it is draining into. We also have underwater data loggers for taking temperature readings as well as light readings. And again, going back to the comfort levels for indoor office spaces, we do have data loggers that will record both temp, RH, and CO2. And then also, lastly, which has been kind of a bigger thing coming up recently, is green roof monitoring. We do have quite a few sensors that are approved for green roof monitoring, mitigation, making sure you're making use of your stormwater runoff, things of that nature. So we have several different options for accessing the data from your loggers. The first one we'll go over is our USB data loggers. These are pretty much designed for short-term use, just to trend data with a manual offload. And they're really very easy to set up. Essentially, you connect the data logger to a computer running our free HOBOware software, and that's where you would set up the logging interval, when you want to start, when you want to stop, what to do in the memory fills, and you can also give the data logger a name. That becomes helpful if you're deploying these in multiple office rooms or conference rooms. So when you offload the data from them, the data file will have the name of that logger attached to that data file, so you can correlate what file went with what location you're recording. Once you launch the logger, you simply secure it in place and let it record its data for a set amount of time. At the end of its deployment, you simply reconnect it to your computer, offload the data, and then within our HOBOware software, you do have the ability to process, analyze, and present that data. One nice feature about our HOBOware software, aside from having a free version of it, is you do have the ability to export that data file out of the software as either a CSV or XLS file. While HOBOware is very powerful when it comes to giving you the tools to process and analyze your data, we do understand that some people prefer working in Excel or third-party platforms, so we wanted to make sure that that data was easily accessible for them to use a program of choice. And here are just some of our common USB loggers for indoor monitoring. We have our HOBO Temp RH 2.5%, which is the accuracy rating for the RH sensor data logger. The top right-hand corner is one of our more popular data loggers for monitoring office space, more specifically like vending machines or office personnel's desk. You know, typically at someone's desk, they have multiple devices plugged into it. You know, it could be a monitor, a printer, a laptop, any other devices they may have plugged in it. You can essentially put this in line between the power strip and the wall, and it will give you really any type of energy parameter you're looking for: volts, amps, watt hours, kilowatt hours, power factor. So a very useful tool for that. In the center is one of our state data loggers. This essentially is can record either state events or pulses. So if you want to connect it to a relay switch to see, you know, when say a vent was opening and shutting, or if you had a flow meter that output a pulse and you wanted to track GPM or something like that through it, you can connect it to this data logger and it will keep track of that from you. Bottom left-hand corner is just another picture of one of our occupancy and light data loggers. And then lastly, at the bottom right-hand corner is one of our 4-channel thermocouple data loggers. This one, we do carry several common types of thermocouple sensors, but you don't necessarily have to use our sensors with this. You can use any type of third-party sensor as long as it has that sub-miniature connector for it. We carry Type J, Type K, and Type T sensors, but there is also Type R, Type N, and I know there's a few other ones, but they're slipping my mind right now. But the ones we carry are typically the most common ones that you would see in the field. And here's just some of our data loggers in action. Again, top left-hand corner is one of our thermocouple data loggers. That's probably connected to like an autoclave or something along that lines. Top right would be one of our temperature and relative humidity data loggers, which actually has its sensor at the end of a 6.5-foot cable. This can prove to be beneficial if you're trying to track temperatures, within, say, an environmental chamber or something like that. That allows you to keep the data logger outside, so you can have that visual reference while feeding the sensor into the actual chamber. Bottom left-hand corner, again, one of our occupancy and light on and off data loggers. And then lastly, bottom right would be our motor on and off data logger. This one's actually a really neat device. It's very similar to the bottom left one, our occupancy data logger, where you actually calibrate it to detect the presence of current from an AC motor. So essentially, it has 4 rare earth magnets on the back of it. You put it on the motor, and you essentially show it what it looks like when the motor's on, show it what it looks like when the motor's off. Then from there, every time that electric motor does that state change, it will tell you when that state change happened, and it actually has a running counter on it showing you how long it ran for during its deployment. So when the motor kicks on, that timer would start. When the motor stops, that timer stops as well. All right. Next, we're going to go over our Bluetooth data loggers, which these ones, not only can they be standalone, but they are also part of our IoT family, which we'll touch base on in a little bit. So when using our Bluetooth-enabled data loggers, they are a versatile, low-cost solution for monitoring a wide array of measurements, whether that's temp and RH, AC current, AC voltage, CO2, VOCs, things of that nature. We have a whole suite of data loggers and sensors that can capture that information. These do streamline the data collection with a convenient wireless setup and download from hard-to-reach locations. As you can see in this illustration, it may be up on a ceiling, something like that. And this data actually downloads right to your mobile device or to a Windows computer running our free HOBO Connect app. These are compact, battery-powered, and easy to deploy. These can be beneficial for both short-term and long-term deployments, for the fact that the Bluetooth signal between the logger and your mobile device, you do get about 100 feet line of sight range. So say you're doing a project in a school and you're monitoring temperature and relative humidity, or temp RH and CO2 in classrooms. Instead of having to walk into the classrooms each time to offload the data from it, essentially, as long as you can stand outside that door, and as long as you're within about 100 feet line of sight range from it, you'll be able to connect to that logger, offload the data from it without even having to enter that room. And again, same with hard to reach places. So say you wanted to tuck a Bluetooth temperature and relative humidity data logger up inside some ductwork or an HVAC vent. Instead of having to climb up there each time to offload it, you simply just stand underneath that vent, connect to the logger, and then you'll be able to do your configuration and data offload. So with our HOBO Connect app, it does allow you to easily locate and view all the loggers that are within that 100-foot range, and no pairing is required. So any data logger that would be within the range of your mobile device, it will populate on your available devices screen to connect to. Now, if it is password protected, which you do have the ability to do with our data loggers, the Bluetooth ones, I should say, you will need to have that password in order to gain access to it. Once you locate the data log you want to work with, you simply tap on that device to connect to it. And that's where you'll go through your configuration process of when you want to start, when you want to stop, how often you want to take a measurement, what to do when the memory fills, or also if the logger, maybe you forgot where you had placed it, it's in the room, you see it on your app, but you can't actually find it in that room, we do have a page option with many of our data loggers that they will start to beep, which will help you find that data logger if it was tucked away in an obscure place. And then again, part of the configuration process, when you select the logger, you will be able to set the logging interval, perform any alarm notifications, i.e. setting thresholds on, say, temperature or relative humidity or current, and then adding that password protect feature I had mentioned, and then also starting and stopping the device. Once you're done with the deployment, you simply reconnect back to the logger. You can download that data and view it within seconds. And then right from the app, you can actually share the data file. You can export that data file as an XLS or CSV file if you plan on opening it in Excel or any other program that uses that file format, or you can export it as a HOBO file, which would allow you to open it up and analyze and manipulate that data within our HOBOware software. And lastly, you can export a .png file, which essentially is a picture file. Within the app, you do have the ability to view that data in graphical form, which is illustrated on the cell phone to the right of your screen right now. So depending on what measurements it had, temp and RH, you would be able to see those and, where there were spikes and drops during its deployment. And here are a couple of our newest building performance Bluetooth data loggers. We have the MX1104, which is a temperature, relative humidity, light, and analog data logger. So essentially it has a built-in temp, RH, and light sensor. And there's also an analog port on it, which would allow you to connect one of our self-describing sensors to it. And then below that is our 4-channel MX1105 Bluetooth analog data logger. No built-in sensors with that, but as I mentioned, we do have a whole suite of sensors that you could connect to that, anywhere from monitoring current, temperature, to gauge pressure, differential pressure, things of that nature. These are designed to withstand harsher than normal work environments, as they do carry an IP54 rating with them. They do feature an LCD display screen on that, which gives you easy viewing of its current conditions, or if you need to do spot checking during its deployment. We did release a suite of self-describing sensors for fast, easy deployment. And essentially, the self-describing sensors, there's electronics built into it that when you plug it into the data logger, it automatically knows what type of sensor is plugged into it. So instead of when you're configuring it, having to say, channel 1's a temperature sensor, channel 2 is a CT, channel 3 is a 4 to 20 milliamp cable. The logger, those sensors will automatically identify themselves to the logger, so it does save some of that setup time. We did do an improvement on the input section with these, where they do have a locking mechanism for it, which ensures that the cables stay securely in place, even if it's the data logger's knocked or someone accidentally tugs on it. These are one of our more larger capacity data loggers, where they can store up to 1.9 million measurements before the memory fills up on them. And typically you do get about a year's life out of the batteries at 1-minute logging intervals or greater. However, the logger itself can record data as fast as once a second if needed. And here's some of our other commonly used indoor Bluetooth data loggers. The top left is one of our most popular indoor temp and RH data loggers, which is the MX1101. This one has both an audible and visual alarm. It can store, I believe it's up to 84,000 measurements before the memory fills. Next to that, the top right-hand corner is our one of our MX2300 weatherproof temperature and relative humidity data loggers. Again, it does have an integrated temperature and RH sensor. This one essentially can withstand any type of environment, whether it's rain, snow, sleet, hail. The only thing you can't do is take it and submerge it. Also regarding temperature, these ones can be exposed to temperatures as low as -40 degrees, all the way up to 158 degrees. Bottom left-hand corner is one of our more cost-effective temperature and light data loggers. This data logger was designed for water, underwater use, but all it essentially means is that it's waterproof, so you can certainly use it indoors if needed. It will give you a temperature reading, and then also you will get a light reading in the form of lux or lumens, whatever measurements you choose at the time of configuration. And then lastly, and this was actually very popular during the COVID era, is our carbon dioxide, temperature, and relative humidity data logger. Monitoring CO is a very cost-effective way to make sure that your HVAC unit is cycling air efficiently or on a set schedule. I believe if it was the ASHRAE standards, I want to say it needed to happen. It was either 2 or 3 times an hour, I believe. And then monitoring that CO2, you will be able to see if your HVAC system is cycling that air within those specs. And actually, another nice feature about this data logger, this is one of our few data loggers that not only is it Bluetooth enabled, it is USB enabled. So you can either use the app to work with that data logger or connect it to a computer with a USB MB cable and use our HOBOware software to work with it. Also with that, you do have the ability to plug this one into AC power. And essentially, whether you have an iPhone or, say a Google-based device, essentially that little wall wart that you get with that, you can just purchase one of those. You plug that USB MB cable into that, plug it into an AC outlet. Now this data logger will run off of that AC power. But if there's ever a chance that, or God forbid, you lost power of the facility, the logger will still continue to log data running off of its battery backups. And here's just a list of some additional measurements you can take with our Bluetooth data loggers, specifically our MX 1104 and 1105. Again, temp and RH, and from that you can actually calculate dew point. The 1104 does have that light intensity sensor in it. We do have current transformers that you can connect to that data logger that come in a few different ranges. They come in as a 2 to 20, 10 to 100, 20 to 200, and 60 to 600 amperage. We also have AC voltage sensors, DC current sensors, DC voltage, pressure, air velocity, compressed airflow, which if you need to monitor the CFM of, say your compressed air system or something like that, we do have sensors available for that. Differential pressure, if you're looking to see if your building is holding pressure or a specific room is a positive or negative pressure versus the adjacent room or hallway. Gauge pressure, and 4 to 20 milliamp. All right, and as I mentioned before, our Bluetooth data loggers, you can use them as standalone, but they can also be part of a remote monitoring solution, or as we like to use the terminology nowadays, an Internet of Things solution. And that's when you incorporate our MX gateway with our Bluetooth data loggers. And essentially, the MX gateway will give you near real-time measurements from any data logger that's within 100 feet line of sight range to your HOBOlink dashboard. With this setup, even though the logger in standalone mode can record as fast as once a second, with the gateway, you are limited to a once-a-minute logging interval. And up to 100 data loggers can connect to a single gateway, again, as long as it's within that 100 feet range from the loggers. From here, you will have the ability to receive remote alarm notifications via text or email, and that could be for an out-of-range sensor, if a high or low threshold was set on temperature RH or something like that, you would receive that notification. low battery, stopped logger, or if a data logger had happened to go missing, i.e. it was told it was supposed to be sending this data to the gateway, and the gateway didn't receive it, any data from it on its logging in full. The gateway is both Wi-Fi and Ethernet enabled. With Wi-Fi, you essentially just need to put in the SSID and password for it, and from there, it will use that information each time it connects. Going Wi-Fi, you will need to power the device via AC with the included power supply. There is also an internet port on it, which if your facility or your client's facility offers power over Ethernet, you can power the device that way, or if not, again, just use the included AC power supply. And this gateway works with all of our MX series data loggers, so both our indoor and outdoor data loggers. I do want to stress, though, that the gateway is an indoor device, and it's designed to be in a dry, non-condensing location, so I certainly wouldn't recommend placing it outdoors, but you can use our outdoor data loggers inside with this device, or even if you need to do, say some temp and RH monitoring in a greenhouse or something like that, that would be an acceptable deployment. I just wouldn't recommend, again, placing it outdoors in the elements. Lastly, we do have web-based systems. And this is more so for long-range wireless internet access, and essentially you can use it for short-term deployments, but they are ideal if you are doing any type of long-term studies. And this setup starts with our RX remote monitoring stations, and we actually have two options for these. The first option would be our RX 2100 station. This is a small, compact, versatile, and low-cost station that communicates its data to the cloud using a cellular connection. You can choose a few different ways on how this device is powered. You can use it, configure it with AC power, where it'll include an AC adapter, and then user replaceable AA batteries for battery backup. If you are deploying these outdoors, we also have it available with an integrated 1.7 watt solar panel, and that comes with a rechargeable battery, which essentially that integrated solar panel keeps trickle charged during the day, so it runs off of that battery power, during the twilight hours and overnight. This one does support 5 of our plug-and-play smart sensors. Smart sensors are very similar to the self-describing sensors I had mentioned earlier for our MX 1104 and 1105 data loggers, where when you plug that sensor into this device, there is electronics in it that tell the data logger what sensor it is. So it saves you some time during the configuration process. And we have this available with or without our HOBOnet wireless sensor network or integrated water level and flow sensor. And essentially what that means is you can get it configured with just those 5 ports, or you can choose to have it with the built-in HOBOnet manager, which will allow you to work with our wireless sensors. And also we have a remote water level sensor that you can connect to this device. The next option we offer for our RX series, which is our flagship station, and that is the RX 3000 remote monitoring station. This is a robust, flexible, rugged station with, again, just like the Micro RX, with cellular communication to the web. This one supports up to 10 of our plug-and-play smart sensors. And then also on the inside of it, there are 2 module ports on it, which allows you to interchange those modules. So you could use, you could connect our HOBOnet wireless sensor manager to it and a water level sensor. We also have an analog module, which would allow you to connect up to 4 four-party sensors that output an analog signal, i.e. 4 to 20 milliamp or DC voltage, and require excitation power. And then we also sell a relay module which that could be prove beneficial, if you want to be alerted or have something taken action if, the station was to have an alarm triggered. So for example, say you had a low temperature threshold set up on one of the sensors, and you wanted, once that temperature hit that reading, you wanted it to, turn on a beacon light so it could alert someone that, maybe the refrigerator that temperature sensor was monitoring has now gone above or below its set design. That relay module would be able to trigger that beacon light. Also working with some outdoor applications, if you're monitoring soil moisture and the moisture gets too dry or the temperature gets too low and you're trying to protect your crop from frost, you could program one of the channels on that relay module to turn on your sprinkler system for you. And now a little bit more about our HOBONet wireless sensors. So unlike our Bluetooth data loggers with the gateway that use, again, that Bluetooth technology, our HOBONet wireless sensors utilize the 900 megahertz radio band here in the United States, which essentially will get you about 1,500 feet to 2,000 feet line of sight from sensor to RX station. On top of that, it does form what we call a self-healing mesh network. So if for some reason a sensor is out of range or out of line from the RX station, that sensor can actually pass its signal through other sensors in line, making up to 5 hops to get that signal back to the RX unit. These systems are scalable, which will allow you to connect up to 50 of our wireless sensors that stream their data back to the cloud-based station. These are very easy to deploy and set up. It's essentially just a matter of putting the sensor in search mode, putting the RX in search mode. Once they make that handshake, you're good to go. There's nothing else you need to do after that. There is an LCD screen on both the sensor and the station. Doesn't give you any readings, but it essentially gives you important information. What's the signal strength? What's the battery strength? Is it connected? Is it not connected? Things of that nature. We have sensors that support a wide array of measurements for both indoor and outdoor environments. It also does have onboard memory, and that ensures that there's no data loss. And when that becomes helpful is, say all of a sudden your cell service goes down in your area and the device goes to make a connection, but it can't. It will keep on trying to make that connection, but at that point, what it does is it stores all its data locally on the device. And I believe it's a couple million measurements that it can store on there. And then essentially once your connection is reestablished, it will do a batch upload of all of that data that was stored locally to the cloud. So you're ensured never to lose any valuable data. The sensors themselves are powered by 2 user replaceable AA lithium batteries, or for our outdoor ones, they do have a built-in solar panel, and those ones would ship with rechargeable AA batteries. So HOBOLink, again, with it being a web-based application, you essentially can access it 24/7 from any device that you use to get onto the internet. So whether that's a computer, desktop, laptop, even a cell phone and tablet, you can certainly use that to look at your data. This HOBOLink does allow you to verify the RX station and the HOBONet sensor status remotely. You can program your alarms through HOBOLink. So if you need to ever make changes to those parameters, you don't need to necessarily go to where the station is. You can do that right from the comfort of your own home. You also have the ability to configure dashboards that allow you to highlight your most important measurements. Within HOBOLink, we do have an integrated Google Map feature that allows you to easily display where your stations are located within your facility, as well as what their current readings are. And then within HOBOLink, you also have the ability to configure calculated channels, such as dew point, which dew point essentially is a calculation for temp and RH. With our rainfall sensors, you can accumulate, total rainfall for, past hour, past day, past week, past month, and then also ET, also known as evapotranspiration. And here's just a screenshot of the map view within HoboLink. Again, this is a large facility that someone has one of our RX3000 stations set up at. As you can see, it does show you the path that each sensor is taking to get back to send its signal to the RX. And also it has what its current reading is as well. If you do notice, while some of the sensors are connecting directly, some of the stations, some of the sensors that are in the left and right wing of this facility are passing their signal through other sensors in line just because they couldn't reach the RX station on its own. So a couple things to consider when you're choosing your solution for data logging. Do you need just a standalone data logger, or is this something that you would like cloud-based or web-based access to? We have options, obviously, for both of those, as we had discussed earlier. Another thing to take into consideration, do you need remote alarm notifications? Do you want to know, say you're monitoring a compressor or a chiller or an HVAC system. Do you want to know if the current was to go above or below a certain threshold and get notified when that happens? Or is it something where you're just going to view this data afterwards to look at trends? That certainly helps decide on which option may best suit your needs. And also, how long is your deployment? Is this something that you're just going to place for a few hours, a few days, or is this something where you're looking to use that as more of a permanent solution? And then also, is this your facility, or is this going to be your customer's facility? While our gateway is Wi-Fi and Ethernet enabled, you may necessarily not want to rely on your client's internet access to get your data. At that point, that's where our cellular-enabled RX stations could become beneficial. Also, another thing to take into consideration with Wi-Fi Ethernet connected devices is if there's a power outage, do you still need to get that data during that power outage? Typically, when you lose power, that means that your internet goes down. Again, that's another area where our cellular stations prove superior. Even during a power outage, the stations will still use that cellular network to communicate their data to the cloud. So, for example, say you're monitoring a pharmaceutical facility, and regardless if there's power or a power outage, you need to make sure that these refrigerators or incubators that are storing, multi-million dollars worth of product are staying within the FDA compliant temperature range. And you need to ensure that if it does go outside of that, you will get an alert. That would be definitely a benefit for our cellular enabled stations. And then lastly, how do you go to power your device? Do you need something that is truly battery operated because it's in a remote or obscure location where you won't have access to AC power? Or do you want something where if there's a wall outlet available, you could plug it into it and then have it run off a battery backup if there was to be a power loss? And then also, something to consider is, do you need to share this data, or how would you like to access your data? Is this something where you want to offload this data file and be able to instantly share it with colleagues, or is it something where you're going to offload it to a computer, store it in a database to analyze later on? And from there, what I did want to touch on here is just some frequently asked applications that we get about several of our indoor data loggers. And actually, for this one, we're going to start with an outdoor application, while it does pertain to indoors. And just because this is something that's come up recently, or I should say more recently, due to the change that we are seeing in climate. And I've been asked a lot of, what are the advantages to installing a green roof? Well, first off, covering a roof with soil and plants, it can pay off through the mitigation of stormwater runoff, which offsets interior heating and cooling costs. Essentially, if you have stormwater that's just running off, that's going into a drain, then essentially is making its way out to a river, you could use that stormwater to actually water your garden up there and help grow sustainable, produce or flowers or vegetables. For the employees in this building. Also, having a green roof does help keep down your heating and cooling costs. And it does dramatically increasing the roof's membrane life. Obviously, with solar radiation beating down on these roofs, it can speed up its deterioration process. Having something like this in place will certainly get you longer life out of it. And also, one of the biggest features to installing green roofs, especially in a city environment, is to help reduce this urban heat island effect that we've been hearing a lot more of lately. Essentially, with all the black roofs that we have in the cities, it is causing these cities to heat up more than normal, and this heat gets dispersed over areas where some people who may not have tree coverage are suffering from more adverse effects of this heat due to this urban heat island effect. From there, we get a lot of questions of, well, what do I need to monitor a green roof? A web-based station is typically ideal here because it enables our users to monitor the green roof conditions, from their office without having to physically go up to the station itself and offload the data from it. With that, typically you want to monitor 2 rain gauges. Typically, that would be one for the rainfall, one for your stormwater runoff, 2 soil moisture and temperature sensors. Solar radiation sensors is ideal to see how much light you're getting from the sun, air temperature and relative humidity sensors, as well as wind speed and wind direction sensors. And again, having all remote access to this data, this allows you to make informed decisions of, well, let me check to see what the moisture is. Is it low moisture? Well, let me go up there, or let me turn on the irrigation system for it. Again, helps you from either overwatering your crop or underwatering your crop, which is ideal to growing, to having a successful crop in an environment like this. Now this gets more into our indoor monitoring, and I get asked a lot, what do I recommend as a simple solution for monitoring HVAC systems to ensure optimal performance and proper in-air quality in a building? With this one, I always recommend our CO2 / temperature / relative humidity data logger. Monitoring CO2, as I mentioned earlier, is a cost-effective way to calculate the air exchange rates in a room. And again, the 1102 does give you this reading. It's easily deployable, and it will help ensure that you are maintaining compliance with the current ASHRAE standards for that air circulation. This, again, as I mentioned earlier, is a compact battery-powered device for easy installation. It is Bluetooth. It does have a large LCD screen on it for doing spot checks, and also has audible and visual alarms should the CO2 temp or RH go above or below a user-defined threshold. Another common application question which pertains to HVAC systems is best practice for connecting sensors to an air compressor and the HVAC system. Typically with an HVAC system, ideally what you want to do is monitor the outdoor air temp, so you get a good idea of what the conditions are outside. Then your direct or input air temp, your return air temp, and then also your mixed air temperature readings. Typically from taking those 4 to 5 different readings, you'll be able to get a good idea or a better understanding of the efficiency of your system and if it's running optimal or not. In this illustration, we're actually showing 2 of our data loggers taking these 5 measurements for you. The one inside the ductwork, again, is our 4-channel MX1105 analog data logger. Then for your outdoor air temperature, you can use one of our MX2300 weatherproof data loggers, and place it up inside of a solar radiation shield to get a very accurate air temperature and relative humidity reading to do a comparison of that outdoor and indoor conditions. And again, these data loggers allow you to apply a data logger to industrial machinery. It monitors production equipment for uptime and downtime. And the most common loggers used on this, as I mentioned, are our MX2300 series with our MX1105 4-channel data logger. You can also use one of our current transformers with the MX1104. So if there was a, say a compressor motor or a fan motor you wanted to monitor amperage on, you could do that. And then also we have, as I showed you earlier in this presentation, our UX90 motor on and off data logger to give you runtime of that compressor or fan motor. And here's just another example of a deployment of that. Okay. Now, again, what is a safe, inexpensive, and simple solution? And here's the key thing that doesn't require an electrician to identify sources of energy waste or, say, identify potential savings. Not to beat a dead horse, but again, our UX90 005 and 006 data loggers are ideal for this. It does not require you to go into the panel whatsoever. Essentially, you can set this data logger anywhere you need to take a light reading, and it will give you that data of when those lights are on and off, and then more importantly, was there people in that room when that light was on versus when it was off. These loggers are calibratable, so you can set them to the light levels within your room to ensure highly accurate and reliable readings. There is an LCD screen that displays a signal strength, enabling proper logger placement, from where the light source is to versus where it should be for picking up occupancy. With these ones, if you are in a building or in a room, as shown in this picture here, that has a lot of windows on it, we do recommend using our light pipe accessory to eliminate false triggers from the ambient sunlight. And essentially the light pipe just goes on the top of the data logger where that sensor is, and then you can just feed that light pipe up into the lighting fixture, so it will only detect light from when that fixture goes on and off. Most conference rooms, and a lot of even small office rooms, there's only one light switch, even though it may be controlling multiple lights in that room. So it's typically just monitoring one of them will give you a good idea of if all the lights were on or off in that room. Okay, and again, sometimes there is a little bit of confusion on the different types of wireless networks and how to choose which one is best for your project. So again, our Bluetooth data loggers use what we call a star network. Data only goes to the gateway, and the gateway must be centrally located. So essentially, you can have Bluetooth data loggers spread out throughout an area as long as they're within that 100 feet line of sight range. But they only talk to the gateway. They won't talk to other data loggers that are in line. Whereas a remote monitoring station with our HOBOnet sensors, these use mesh network. Excuse me there. So if a sensor doesn't have a clear line of sight back to the RX station, it can pass its signal through other sensors in line, making up to 5 hops. While we do recommend having the RX centrally located, it doesn't have to be. The sensors themselves are smart enough where they're always going to find the best path to get the signal back to the RX station. All right, and then another one, interested in sensors for monitoring both indoor and outdoor conditions for use in automated controls, including wind, rain, etc. Hobo, as you saw in the beginning of the presentation, offers a wide variety of loggers for outdoor, weather, and underwater applications, whether that's water quality, water level, standalone outdoor data loggers, or full complete weather station kits. Our data loggers, we do generally give a rule of thumb that a single data logger can cover 2,500 square foot. And we do often get questioned, how does this apply to office spaces or large facilities? If you have a wide open room, such as in this picture, we always recommend placing the data logger next to where your thermostat is. But essentially, every 2,500 square foot is where you should place a data logger to get a better understanding of what the conditions are in the whole space. Now, there's always going to be variations, whether it's, close to the ceiling, close to the floor, is it near windows, is it directly under a vent, things of that nature. So you definitely want to take that into consideration for when you're doing its deployment. And also, when when you are going to deploy these, listen for specific complaints. If someone's saying that, they're constantly cold because there's an air-conditioned vent directly above them, or, they're always getting blasted with heat during the wintertime, where a person down, 15 feet away is saying that they're cold. Trying to identify problem areas and working from there can certainly help mitigate any comfort issues within these types of spaces. And how does this rule apply to large facilities? Again, in a large facility, what you'd want to do if there's any partitions, partial walls, things like that, you may want to consider placing a data logger in there. In this illustration, you do see that there's some glass partitions. Are there vents inside of there, or are they only on the outside of where those partitions are? You may want to take some measurements inside of the partitions as well as outside to get a better understanding, if you're getting good air circulation, or is it comfortable in one area but not comfortable in another area? Also, are you a south-facing building, or is it something where only one side of your building gets direct sunlight during the day? That obviously can have an effect on giving you various temperature readings throughout your facility, and putting data loggers in that and those types of problem areas will certainly give you a clearer picture of what's going on. Next, I'd like to move on to an application story here. And this is actually a company called Enco, who had used some of our data loggers for a new product they're designing. And essentially, they're doing thermal performance monitoring with our remote monitoring stations. They had developed an advanced material that essentially was to help decarbonize the built environment. While they were developing this, they relied on our accurate monitoring equipment to measure thermal performance in both a lab and field scale experiments to rapidly prototype innovative temperature regulating building products that enhance building performance. And here is actually a picture of their failed scale test that they did, where essentially what they did is built two identical enclosures with the same air conditioners installed. They subjected both of them to the same environment, which is actually done in an extremely hot and dry Arizona climate. And with Enco's adaptive materials technology applied to one of the buildings, and then the other was only covered with some commercially available products, which served as the control for this study. From the graph here, you can actually see that from the data that was collected, Enco was able to easily view trends within HoboLink, our cloud-based platform, and the building that was coated with this adaptive material technology showed much lower power consumption to maintain the required temperature, which essentially illustrated the success of their product and is now leading them to start to deploy this on a larger scale pilot study. And again, with the help of our data loggers, they were actually able to put some fact and data behind their theories.
Shannon, can you hear me?
Yes, I can.
Okay. I just wanted to make sure you could hear me when I jump back on. I know that we've had quite a few questions come in, and
All right.
people are extremely engaged in all of the information that you are sharing. We are almost out of time, actually, for today's event. Which is...
All right. Well, if we have a few minutes, I'd be happy to go through and answer some questions that have come in.
We have a couple minutes. I know we've had quite a few that have come in. So if you don't get your question asked in the next 2 minutes or so, we will follow up with you. A member of the team will follow up with you as soon as we can. So yeah, let's jump in. Let's get through 1 or 2 questions before we close out, because I know we want to be mindful of everybody's time today. So
certainly.
Yep. And so let's start off with this question that just came in about 15 minutes ago. Which logger would you recommend to monitor energy for manufacturing equipment in an industrial plant?
Certainly. So with that, it really depends on what are you looking to monitor here? Are you looking for energy consumption, or do you want to measure just amps and volts? Amps and volts, I would recommend are, again, MX1105 4-channel analog data logger. You can connect CTs to that, as well as voltage sensors, which will give you, again, your voltage and current reading. If you're looking for kilowatt or kilowatt hours, we do have a very cost-effective kilowatt hours monitoring kit, which essentially you piece together based off of the setup of your panel, or, the piece of equipment you're trying to monitor, whether it's single, split, 3-phase, and then the expected volts, expected current, and then from there it will give you a kW or kWh reading.
Great. Thank you for going into the different options there. Now, I think a good way to wrap this presentation up would be, if somebody wants to get started, if a client wants to get started, what are the next steps? What do they need to bring to you?
My contact information, I believe, is up on a holding slide.
Yep.
I did just want to reference real quick. Right now, we are looking at some online resources and upcoming webinars we have, but I will jump to my contact information as well. Please feel free to reach out to me directly, and I'll be more than happy to answer any questions you have or get you set up on your next monitoring project. I know I did cover a lot of information throughout the presentation, and I'd be more than happy to go in depth on specific projects with anyone.
Well, thank you. We really appreciate your time today. We really appreciate all the work that you, as well as the rest of your team at Onset, put into today's webinar. If you have additional questions, please feel free to submit them in the survey that's going to pop up on your screen when I conclude today's event. Again, thank you so much, Shannon. We really enjoyed having you on with us today. And I am sorry to the attendees that we didn't get a chance to answer all of your questions, but I'm fairly certain this webinar could have lasted another hour, and we might not have even gotten to all of the questions then. So we appreciate your participation today. And at this point, I am going to conclude today's webinar, and I hope everybody has a wonderful day.